Let's start with a little bit of vocabulary. We know that 12 is equal to 6 times 2, and 6 is called a factor and 2 is called a factor. Things that we multiply are called factors, and we get a product. 6 times 2 is a product. 12 is also equal to 4 times 3, so 4 is also a factor of 12, and 3 is also a factor of 12. Now 12 is also equal to 2 times 2 times 3. 2 is a factor of 12, and it's actually a factor twice, and 3 is also a factor of 12. Now, the 2, 2, and 3 are called prime factors because we cannot break these up into factors except for 1 times themselves. In other words, 2 is equal to 1 times 2, but we can't break it up any other way. So these are prime factors. In number 1, we want to find the prime factorization of 420, or in other words, we want to break 420 up into prime factors. So here's what we're going to do. We're going to solve this one step at a time. First, let's write 420 as the product of two factors. Now, since 420 ends in 0, we know one of the factors could be 10. So one easy factorization is 42 times 10. That's because 42 ends in a 0. All right, and then we can break these up further. 42 is 6 times 7. 10 is 2 times 5. All right, we can't break up 2 or 5 further. These are both prime numbers. 7 is a prime number, but 6 is equal to 2 times 3. So once we have prime numbers at the bottom of each one of these branches, then these are our prime factors of 420. So the prime factors are 2, 3, 7, 2, 5. Now I like writing these in order, smallest to largest. So we have 2 times 2, we have 2 2's. Then we have a 3, then a 5, then a 7. All right, now let's find the prime factorization of 480. So again, since 480 ends in 0, one easy factorization would be 48 times 10. So we'll start with that. All right, 10 is 2 times 5. 48 we can break up as 6 times 8. All right, let's say, or 8 times 6. And 8 is 4 times 2, 6, 2 times 3. All right, here, this is a prime, 2 is a prime, 3 is a prime, 2 is a prime, 2 is a prime, 4, 2 times 2. All right, now on the bottom branches, we have all prime factors. So let's write these out. How many 2's do we have? 1, 2, 3, 4, 5. 5 2's. And then we have a 3, and then we have a 5. So that's our prime factorization of 480. We're going to start with a little bit of vocabulary. Let's look at these two numbers, 6 and 15, and we want to find their greatest common divisor. A divisor is a number that divides evenly. A divisor of 15, and numbers that divide evenly into 15 would be, let's say, 3 and 5. Now we want the greatest common divisor, that is, the largest number that divides both 6 and 15. So let's just think about numbers that divide 6 and 15, like let's say 3 divides 6, and 3 also divides 15. 2 divides 6, 2 does not divide 15. 6 divides into 6, but does not divide into 15. So the largest number that divides both 6 and 15 is 3, and that's the greatest common divisor. Now we want to figure out what the least common multiple of 6 and 15 are. So first of all, a multiple of a number is something that the number divides into. Okay, for example, let's look at multiples of 6. 6 is a multiple of 6. 6 times 1 is 6. 12 is a multiple of 6. 12 times 2, 6 times 2 is 12. So 12 is a multiple. 6 times 3 is 18. 18 is a multiple. 6 times 4 is 24. 24 is a multiple. These are multiples of 6's. Let's look at multiples of 15. 15 times 1 is 15. That's a multiple of 15. 15 times 2 is 30. That's a multiple. 15 times 3 is 45. That's a multiple. 15 times 4 is 60. That's a multiple of 15. So these are all multiples of 15, and 15 divides into those numbers evenly. Now the least common multiple is the smallest number that is a multiple of both 6 and 15. So let's look at multiples of 15 and think about whether or not 6 is also, whether or not the number is also a multiple of 6. So let's start with 15. All right, well, 6 doesn't go into 15 evenly, so 15 is not a multiple of 6. Let's do 15 times 2, which is 30. All right, 30 is a multiple of 15, and it's also a multiple of 6 because 6 goes into 30 evenly. 6 times 5 is 30. So 30 is the least common multiple. All right, so we use just our common sense to figure out what the least common multiple is and what the greatest common divisor is. Well, and we did that in this case because we could do that in this case because 6 and 15 are relatively small numbers, but we will have a technique for finding greatest common divisor, least common multiple when we start with larger numbers, so we'll see that in a minute. Okay, so now we want to find the greatest common divisor of 300 and 840. Well, these are what I call relatively large numbers, so what we'll do is we'll start, our technique requires that we get the prime factorizations of both, so let's do that. All right, so 300 ends in 0, so 30 times 10 is one factorization, and let's keep going. Here we have 30 is 5 times 6, and 6 is 2 times 3. And 10 is 2 times 5. So now I think we're down to primes, 5, 2, 3, 2, 5. These are all primes. Let's write them in order, starting with the 2. We have two 2's, so let's write 2 times 2. And let's see, we have a 3. We have a 3, and we have two 5's. So there's our prime factorization of 300. Now let's look at 840. So we'll start with 84 times 10. Again, 840 ends in 0, so it's equal to 10 times something, 10 times 84. And let's break up the 10 into 2 times 5. And we can break up the 84 is 4 times 21. All right, and this is 2 times 2, and 21 is 3 times 7. I think we have primes now at the bottom of these branches, 2, 2, 3, 7, 2, 5. Let's put them in order. We have 3 2's, 1 3, a 5, and a 7. So here are our two prime factorizations, and now for our technique, what we're going to do is we're going to line them up. Line up the prime factorizations. We can start with either one. All right, let's say I start with this first one here. Just write it out. Okay, now we'll line this one up underneath, and we're going to put matching primes underneath matching primes. So I'll put this 2 right here under this one. The next 2 I'll line up under this 2. And now I have another 2, nothing to line it up with, so put it off on the side, make its own column. The 3 I could put right here, line it up. The 5 I could put here, line that one up. And the 7 I have to put off on the side. I have nothing to line it up with. Now for the greatest common divisor, what we're going to do is we're going to list the primes that have a match. So 2 has a match, and this 2 has a match, and this 3 has a match, and this 5 has a match. And that's it. So this is the greatest common divisor. And now let's just multiply that out. We have 2 times 2 is 4, times 3 is 12, times 5 is 60. So the greatest common divisor is 60. In number 6, we want to find the least common multiple of 30840, the same numbers whose prime factorizations we just got. So let's use those same prime factorizations that we had in the previous example and line them up in the same exact way. So first, the prime factorization of 300, that was 2 times 2 times 3 times 5 times 5, and then prime factorization of 840 lined up underneath, 2 times 2 times 3 times 5 times 2 times 7. Those are off on the side. Now for the least common multiple, what we do is we list basically all the columns. So we're going to list the 2 and the 2 and column 3, and we have a column with 5s, and we have another column with 5s. This is listed as a 5. Even though this one has 2 5s and this one has 1 5, still just listed as a 5. List the column with 2 and list the column with 7. And this is the least common multiple. So that's the technique. Least common multiple, list all the columns, and for the greatest common divisor, only the columns that have a match. All right, now we can just multiply this out. And when we multiply this out, we get 4,200. So that's our least common multiple. In number 7, we want the greatest common divisor of 630 and 84. So same technique we used before. Let's get prime factorizations. So here we have 63 times 10. This is 2 times 5. This is 7 times 9. And here we have 3 times 3. All right, so now we have all primes at the bottom of these branches. Let's list them in order. We have 1, 2, 2 3s, a 5, and a 7. All right, 84, that's 4 times 21. This is 3 times 7. And this is 2 times 2. In order, we have 2, 2, 3, 7. Okay. Now for the greatest common divisor, line them up. We'll match this 2 here with this one. This 2 we have to put on the side. We have nothing to match it with. This 3 will write underneath that first 3, and this 7 can go underneath the 7. Greatest common divisor only lists the columns with matches. So 2, 3, 7. So that's our greatest common divisor. Let's just multiply it out. 2 times 3 is 6, times 7 is 42. And number 8, we want the least common multiple of these same numbers that we had in the previous example, 630 and 84. So let's again line up their prime factorizations. So first, for 630, we had 2 times 3 times 3 times 5 times 7. And underneath the prime factorization of 84, 2 times 3. And here we had times 7 times 2. And now we're looking at the least common multiple. So for that, we want to include all columns. So we have a column with 2s, a column with 3s, another column with 3, column with 5, column with 7, column with 2. So this is the least common multiple. And now just multiply all these together. And when we multiply together, we get 1,260. So that's our least common multiple.